All right, so this is a question from our review pack that is dealing with binomial expansions, then a MacLaurin, and then using a MacLaurin to test a limit. Um, so to start, we have to do the first three of 1 plus t to the negative 1. Well, if we just follow this, this is going to turn into the first term, which is 1 to the negative 1, times the quantity 1 plus negative 1 t over 1 plus negative 1 times negative 1 minus 1 all over 2 factorial, and then t over 1 squared. Well, simplifying that, I end up with 1 minus t, and then that becomes negative 2, so positive 2 over 2, so this just turns into plus t squared. So that is our answer for part 1, or part A, I guess I should say. I'm just going to throw that to the side real quick. We're going to come back to it later on with this. The next part of the question is we need to use a MacLaurin series for cosine x and the result from part A to show that the MacLaurin series for secant x up to and including the term blah is blah. Okay, this is where it gets a little bit tricky because I'm using this 1 minus, this is going to be a mess, 1 minus t plus t squared, and that is 1 plus t to the negative 1. If I want to get cosine involved in this, because secant is in fact 1 over the cosine of x, so I could write secant x as the cosine of x to the negative 1 power. All right, now I want whatever I put in there to be equal to cosine. So in order to make that happen, I'm going to substitute t equals cosine of x take away 1. And if I do that, I would get 1 plus cosine x minus 1 to the negative 1. Well, obviously these 1's go away, and I'm just left with cosine x to the negative 1. Okay, so now what I'm going to do is I'm going to take, and I am going to, that was interesting, find my cosine, and cosine of x as a MacLaurin series is, so cosine of x is the same as 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. Right. So what I can do now is I can substitute, because if t is 1 minus cosine, then what I would have is I would have 1 minus cosine x plus 1 minus cosine x minus 1 plus cosine x minus 1 squared. Okay, but so that subbing in my MacLaurin series for those, I would have 1 minus, by the way, it's cosine x minus 1, right, we got that. So we do 1 minus x squared over 2 factorial is just 2, plus x to the 4th over, 4 times 3 is 12 times 2, 24. And then taking away that 1 at the end. So I'm matching there and there. And then I'm going to add to that 1 minus x squared over 2 plus x to the 4th over 24 minus 1, and then I'm going to square that. Well, let's get some canceling done. That goes away, that goes away, that goes away, that goes away. So my first part of this is 1 minus plus x squared over 2 minus x to the 4th over 24. Now, this would continue on. There'd be another minus, but we're not really worried about those. Now, when I square this, I would end up having to do x squared over 2 times x squared over 2, which would give me x to the 4th over 4. All right. X to the 4th over 4. And then my next one would be x squared, negative x squared. That is a minus there, but because I'm squaring it, I get a positive. So I get x squared over 2 times x to the 4th over 24. So that's going to give me negative x to the 6th over 48. Real quick though, we were only asked to find it out to the 4th power. So I think we can probably stop. Yes, there would be more and more, but as soon as we get to the x to the 6th, like, that's just ridiculous. We don't need to deal with that. Now, combining like terms. So we are at so we have 1 plus x squared over 2 and minus x to the 4th over 24 plus x to the 4th over 4, which would be 6x over 24, right? So that's going to give me 1 plus x squared over 2 plus 5x to the 4th over 24. And I think that's exactly what we were looking to get to. So that is part B, done and dusted. Right. The next question. Let me just get this junk out of my way. And if I move that over there. Now, by using the MacLaurin series for arctangent x and the results from part B, find the limit of, all right, so it's going to be the limit as x goes to 0 of, well, arctangent of 2x. I've got the arctangent of x formula, so it's going to be x times, arctangent of 2x would be 2x minus 8x cubed over 3 plus 2 to the 5th power is going to be 32. 32x to the 5th over 5. And then divided by secant x minus 1. Well, secant of x minus 1 we know is this value here. So because I am lazy, I'm just going to grab that and move it over. But we have to subtract 1 from that. And then obviously we cancel those two because they go away. And I could go further through expanding this, but just getting it set up, it's a 3-mark question. This tells me I need to use my calculator. So I am going to get my calculator out, and of course it is not open right now. Thank you, app install. And I'm just going to evaluate that limit using my calculator. So the Inspire is opening, it is opening, it is not, there it goes. I could cut this out, but what would be the fun in that? Like, I think you enjoy hearing my voice. I think you enjoy hearing the frustration in my voice as I'm struggling to make things work for me. So we're going to add a calculator. I am going to take a limit. So if I go over here, my limit is right there, and I want the limit as x approaches 0 of, this is going to be x times the quantity 2x minus 8x to the third, or to the third, right? Yeah. Divide by 3 plus 32x to the fifth, divide 5, and I am then going to divide that by x squared over 2. Gotta get this right. Divide by 2 plus 5x to the fourth, all over 24. I forgot a multiplication symbol. And if we do all of that, we end up with 4. So that is my answer for that one. We would end up just with 4 is the limit. Okay, I hope that that was helpful.